Thank you. Yeah. Where's the clicker for start? The buttons. Okay. So yeah, I'll just get straight into it. So first thing to note, the sort of stated result of this talk, the abstract, is normalization by evaluation for linear nonlinear logic. But I don't think that's an actually interesting result. What is interesting about this work is how I came to do it, because it's a mechanized in AGDA kind of meta theory project, and I really use normalization by, I'll just say NbE. I really use NbE as a test case because it goes through some nice bits and pieces. You need to worry about scopes and environments and renaming and syntax and all this sort of stuff. So that's what's happening here. So first refresher of NbE in the simple case of simply typed lambda calculus. Um, uh, First, we start by defining a model, which I use this to set notation. I use this funny notation that works well in AGDA of double turnstile as instead of like double square bracket. So it says that with free variables gamma, if we want a value, semantic value of type x times y, then that's going to be a meta-level pair of a value of type x, a value of type y, both in context gamma. Simply type lambda calculus, we can have positive products as well. Why not? And no eta for positive stuff for simplicity. So we tack on some neutral terms of the type. Then functions are a bit more complicated. We have to do this Kripke thing. So the double arrow is for environments and an environment full of variables. That's the set membership symbol. So environment full of variables is a renaming. So this says that we can, we have to have a semantic function not just for gamma, but any context gamma plus that includes as many variables as gamma, and maybe a few more, because maybe we've gone into some binders or something like this. And then, as is my want, I get rid of all these gammas I've been talking about. So define everything slightly point free. So whenever there's a point on top of a logical connective, that means it's pointwise. So that this line means the same as before, where gamma's just been distributed across. We do the points for the disjoint union. It is disjoint, the union. And then for the function thing, it's a bit more complicated. We need two stages. So this bit on the right looks like a pointwise function with gamma plus as the argument. So pointwise function. And then all this other stuff with the renaming and binding the gamma plus. I'm going to get rid of all that and call it box. Because box is a great name. Box is a oh yeah, oh shit, I'm going to do that as well. But box is a good name in this case, so I'll come on to in a few slides time. Yeah, and when we've got the box, we can get rid of the gamma, so no more gammas anymore. And getting rid of the gammas lets us talk about things at the level of sets indexed over contexts. Which have some nice properties because they're related to pre-sheaves over the category of contexts and renamings. But we don't get that immediately, so we have to do some back and forth. And the box is doing some of that back and forth implicitly. It's sort of like you cross over the adjunction in the right way and get the co-free renaming satisfying family. Okay, things I can't talk about is anything beginning with letters RE. And I'll move straight on to the eponymous evaluation. And here we've got environments again, the double arrows, but it's that way for you. This time the environment is saying like in context gamma, we have semantic values in double turnstile for each thing in delta. And looks like a bit of a composition, right? We go from gamma to delta, we go from delta to x, and then eval does the composition. That is by what I call it environment managing recursion on the term. So it's going to do recursion on the term, and when the term has a binder, we're going to need to extend delta at least, but that's going to extend gamma as well. So it's going to sort of clop on like extra, not particularly interesting, but still there, semantic stuff. And we get normalization by this. We use reflects to turn variables into semantics to put them in the environment. The identity environment is not entirely trivial, so watch out for that. Then evaluate to get some semantics, and then reify to turn semantics into normal forms. Okay, so that was NbE refreshed. Now non-linear logic. I'll just say LNL refreshed. We push the tensor product into the linear fragment. Interestingly, fragment has this is exactly as in Benton. So it has negative products functions and this modality G. To get us, so the F and G get us between the two fragments. On the linear side, we have tensor products functions, linear functions. On the intuitionistic side, contexts only have intuitionistic variables in them, whereas in the linear context we have both, and that's quite important. So both linear and intuitionistic in the gammas and deltas that follow. Intuitionistic environments are going to be as before. I mean, I didn't explain what they were before, but assume there's something sensible. The functional representation works. The linear environments, I'm going to define them later because, I mean, they appear in my thesis, but they're somewhat new. So dealing with linearity, again, we want to avoid talking about all these gammas and deltas and stuff, mainly the gammas. The deltas are still okay. What we do if we've got some like tensor introduction rule like this, normally we put a comma in the middle of the rule, but like in a formal sort of mechanized setting, that's kind of annoying for various reasons. Instead, we want to keep the thing on the bottom, the context on the bottom of the rule sort of generic. So we just got some arbitrary gamma, and we're gonna this gamma twiddle, gamma L plus gamma R is a like is basically a way of like dealing out gamma into the two halves. So it'll deal out some of the linear variables into the left, some of the linear variables into the right, but the intuitionistic stuff is going to go on both sides. And I write my data type definitions in like logic programming for some reason. There's also a terrible jump in the slide here. Mind your head or something. So we can package up this this pattern of gamma, and then gamma splits into things, and the things carry on as a what I call separating conjunction in blue. And so these two bottom rules mean the same thing, just different notation. And just for neatness sake, get rid of the like function here things and say like if there's an empty space, that means arbitrary, not empty context. It means arbitrary. Okay, so this appears in like Rauvut et al. 2020 and my thesis. So that's not new. What is new is the LNL's like special source of we want to move between the linear and intuitionistic modes, the L and the I. And normally to do this, we either have a linear context where we say, actually, there's no linear stuff inside here, it's all intuitionistic. or we've got an intuitionistic thing, we could just turn it into a linear context anyway. So that's what these three rules are doing. Again, we've got this pattern of the traditional notation has some sort of restriction on the context at the bottom, whereas mine doesn't. It's generic and not even mentioned. So the blue F, which I call meta F, does it says I take in a linear context. I assert that there are no actual linear variables in here, and then I pass the actual like underlying intuitionistic context onto the next predicate. I have the intuitionistic term of type X. And G does the reverse, but there's no restriction there because they'll work. The one like modality rule I missed is this F pattern matching rule. Doesn't use the meta F and the meta G. It does use the separating conjunction, and also some variable binding, which we love. Okay, and then to the actual result. The model looks like this. Probably the most interesting line is the linear functions. Well, we look at tensor product first. Tensor product is the same as before, but with the separating conjunction rather than the pointwise. So we sort of split up the context as if it were resources. The linear function space, this uses the separating implication, the closure for the separating conjunction. So that's kind of nice. And then F and G both use meta F and meta G. But of course, because F is like object F is handled by pattern matching, we tag on neutral terms of type F of X. Okay, and then oh yeah, that was the thing. This box for the function type is not actually defined yet because I haven't told you what the environments are, but they're like this. So if you're making an environment into an empty context, you need the separating unit to hold of the left-hand context, which means it's purely intuitionistic. And contexts are implicitly tensored together, so it looks like tensor introduction for the other cases. But to get a value of intuitionistic thing, you sort of follow the types and use meta F to get there. This has some nice properties. The one of relevance for the next slide is the one to get an environment inside meta F. They're all to get environments inside the meta connectives, but this one's to get it inside meta F. The third one down says if you're going into an intuitionistic context, then you can get an intuitionistic environment. And evaluation looks like the thing at the bottom. So remember, we have the object G elimination rule. It looks like the thing at the top. The property we were just talking about, I call M's meta F. And evaluation is what we want. The third thing down. There's a bunch of notation, but basically we use the M's meta F property on rel, which is the proof of like being intuitionistic of the context, to move rho like inside an F to become rho prime. And then when we're inside the F, all these meta-connectives are functorial, so we can map. When we're inside, we can evaluate the inside term to give us something of type GA, the semantic GA. And then we get to the end, we've got everything wrapped in F. We've got the thing of type GA, so FGA, and then we use the what is it, the co-unit, I think, or is it the unit? I don't remember. Which you can think about later because I don't have time to explain. So conclusion, this sort of context implicit approach to meta theory works even when we're doing all sorts of crazy stuff with linearity and modes and stuff. So that's nice. Intuitionistic fragment, I managed to keep easy. It's as you would want to do it. And then, yeah, there's implicitly a like separating, non-separating logic in here, but I haven't thought about it. And yeah, let me know if this is interesting at all. Code is there. Thank you.